Okay, so last time we had a look at expanding and factorizing single terms from brackets. And then we had a look at expanding binomials. So binomials are these terms here, and we can multiply them together using the FOIL method. And we can also multiply more than two together using this triple brackets method. But this is how to expand binomials into what's known as quadratics. But what we need to do is we need to now find out how to factorize quadratics back into these binomials. So, first, it would make sense to understand what a quadratic is. Okay, so quadratics are in the form ax squared plus bx plus c equals 0. Now this is an important bit, equaling 0, because sometimes you can start with quadratics that aren't in this form equaling 0. They equal something else. So what you need to do, the first step is to always rearrange it so it equals 0. Now these a, b, and c, a, b, c are constants or numbers. So for example, I could put 3x squared plus 5x plus 2 equals 0. And that would be a quadratic because we have a equaling 3, b equaling 5, and c equaling 2. Like that. But yeah, that's what a quadratic is. Now, what we want to do is we want to factorize these quadratics. So, if we move on to a new slide. So, also it does help to know that on a graph, quadratics come up in two ways. So they can either look like that or they can look like that. But we'll come on to this later. And here are your labels. Okay, so we can factorize quadratics. So let's figure out how to do this. So for example 1, there are actually different cases. So this is case a equals 1. So you can only use this method when that should be a capital A equals 1. So if we go back to our form here, a is the term in front of the x squared, or the number in front of the x squared term. So for example, if we have x squared plus ax plus 15 equals 0, we can see it's in the right form because our c is 15, our b is 8, and our a is 1. And because our a is 1, we can use this method. So this is the first method. So what we do is we can write it out like this. We find out what multiplies to equal c and what adds together to give b. Now, so remember, if you remember our form, put in a different color, ax squared plus bx plus c equals 0. We can see that our c here is 15 and our b is 8. So now we need to find two numbers which multiply together to give 15, which add together to give 8. Bear in mind that they have to be the same two numbers. So you can think about this for a while, but what it ends up being is 3 and 5 3 and 5. Whoops. Because 3 times 5 is 15, but 3 plus 5 is 8. So these 3 and 5 are the numbers which satisfy these conditions. Now, but you might be asking, where do we go from here? Well, we put this in the form x plus 3 times x plus 5. And these are our binomials. All you can see that all I've done is put x plus the first number and x plus the second number. That's all I've done. So that's how you figure it out with when a equals 1. But when a doesn't equal 1, the process is a little bit more complicated. So, factorizing quadratics, case a does not equal 1. So when a doesn't equal 1, here's our example. 4x squared, 19x equals 5. Now, if I write our standard quadratic form, you can see that this isn't actually in the right form, because it doesn't equal 0, it equals 5. So what we need to do is we need to manipulate this equation to get 0 on this side. So what we can do is we can subtract 5. 5 minus 5 equals 0. But remember, when we do something to one side of the equation, we have to do it to this other side. So we also have to subtract this side by 5. And now, what we'll get is 4x squared plus 19x minus 5 equals 0, which is in this form here. Bear in mind, we do have a negative sign, but this plus sign, it's fine. It accounts for negatives as well, because technically we could put a plus here, and minus 5 is our c. So don't worry, it's still in that form. Okay, so now that we've got it in this form, we still have a difference between this, and that's that a doesn't equal 1. So we actually have to do a little bit of work here. So what we need to do is we need to find two numbers that multiply to give a times c. Okay? Instead of just c, we have to multiply it by a. And our second is still the same. It's still adding to give b. So let's figure out what a times c is. So that's 4 times minus 5. And you need to remember this minus as well. So we get minus 20. And then we get b equal to 19. So we want to find two numbers that multiply together to give minus 20, that add to give 19. Well, if you think about it a little bit, you could eventually come to the conclusion that it's 20 multiplied by minus 1 and 20 plus minus 1, like that. We can see this because because we got a minus, we know that we have to multiply a positive and a negative number together to get another negative number. So that's a good indication of what you need to do when you got a negative number. But yeah, 20 times minus 1 is minus 20, and 20 plus minus 1, or just 20 minus 1, is 19. Okay. Right, so, but the thing is, you could say, alright, let's put it into our brackets, x plus 20, x minus 1. But this is actually wrong. and it's because a doesn't equal 1. There's actually another step we have to go through. So this can be step 1, or we can say step 1 is rearranging to get it equal to 0. Step 2 is finding these two numbers, and this is step 3. And step 3 is we need to split this number up into 2. We need to split b up into 2. And we can actually use these two numbers to do that. So let's write this. We're just going to rewrite this equation, but a little bit differently. So we're going to say 4x squared plus 20x minus x minus 5, like so. Now what you can see is that we've basically replaced this 19x with plus 20x minus x, because these are our two numbers. So what you have to do is you need to replace your b value, your bx, with these two x values, like so. Because you can rewrite 20x minus x as 19x. They're the same thing. But now, because we have it in this form, we can find our brackets. So what we do is we split down the middle like this, and we focus on these two individually. So what we do is we see, can we take out any common factors of the left side? So we have 4x squared plus 20x. Okay, so we use the method that we used last time, and we look at the numbers, and we can see they're both multiples of 4, so we can take 4 out. Okay, and we can see that the x's, the x squared and x, are both multiples of x, so we can take x out as well. So if we divide 4x squared by 4x, we just have x left over. And if we divide 20x by 4x, we have 5 left over, like so. Okay, so now that we've got this, our target for this next bit is to get the x plus 5 in the bracket here. So we want to get this same bracket on this right side. So we need to say, what can we take out of this to give us x plus 5 in the brackets? Well, some people struggle with this, but you need to realize that you can also divide by minus 1. So you can take out minus 1. And that means we'll be dividing each term by a negative. And when you divide a negative by a negative, you get a positive. So minus x divided by minus 1 is x. And minus 5 divided by minus 1 is plus 5. And as you can see, we've got the same thing in the brackets. You have to have the same number or the same binomial in these brackets. They have to be the same. Otherwise, you need to go back and manipulate it in such a way that you get the same brackets. Now, the two brackets that you finish with are x plus 5, so the bracket you get here, the repeated bracket, and then your second bracket are the terms on the outside. So it's 4x over here minus 1 over here, like so. So you get x plus 5 times 4x minus 1. Now, that's your final set of binomials. Just a few remarks about this method, because it can be quite complicated. First off, you don't have to order it in this way. Okay, so you can, in this case, you could also order it like this. Like that. Which is just the opposite order of this. Nothing's changed. It's just the opposite order of it's just the opposite order of this here. So instead of plus 20x minus x, we get minus x plus 20x. And also these should have equals 0 at the end. Bear in mind, some questions might not start with equals 0. They might just have this. And then if they do only have that, you don't have to worry about the equals 0 bit. But if they do, make sure to keep it there as well. So yeah, you can order them differently, and sometimes that can help if it's sometimes easier to cancel out. So in this case, we can take out just x over here. We get 4 minus x, 4x minus 1, sorry. And here we could just take out 5, which will be 4x minus 1. We got the same thing in the brackets, and we've got x plus 5 outside the brackets, so we get the same answer. Another thing is you can check your answers. So we can do in fact I'll do this in another color. We can check our answers. So now that we've got this, we can use the methods we learnt in the last video to go from here to back to the quadratic. So we can either use the FOIL method or any other method we want, as long as we understand. So x times 4x is 4x squared. X times minus 1 is minus x. 5 times 4x is 20x. And 5 minus 1 times minus 1 is minus 5. And then if we put those two together, get 19x. And we're back to our quadratic form. So we can always check our answers using that. So now we've learned how to expand and factorize all sorts of values, especially and we've especially focused on factorizing these quadratics when a equals 1 or when a doesn't equal 1. Okay, so as an exercise, I have a few questions that you can do in your own time, and we can go over this later on. Okay, so what we've got is the first exercise is a times a plus b. Exercise 2 is x minus 5, x plus 8, 3x minus 5. So this is the triple bracket expansion. And exercise 3 is factorize 2x squared plus 9x plus 4. And there's no equal 0, so you don't need to worry about that. Just have a go at these exercises and tell me, and we can go over it in the next session.